Boom.
Why do we need to draw the squiggly lines?
I want to draw squigglies.
Squiggly, squiggly, squiggly.
They are called polynomials.
Squiggly. You call them squigglies, we call them squigglies. It's all squigglies.
These are polynomials.
They're not lines.
So the first thing we need to do is what? You got to find the degree. Okay, and how do we find the degree?
Find the biggest thing, the exponent.
If it was FOILed out, if it was all multiplied out, we'd look for the biggest exponent, but this hasn't been FOILed out. So then, oh, please don't FOIL it. Oh, too much work. If it hasn't been FOILed out, if it's written in factored form, then you just add them. Okay, so this is a degree of 4. It does not have a negative in the front, so it has a positive coefficient. So we are looking at an even degree with a positive coefficient, and so the arrows should go up, up, okay? Or if we were to write that formally, we would say as x goes to negative infinity, y goes to positive infinity. As x goes to positive infinity, y goes to positive infinity. But that is not our final answer. It's merely helping us draw. And since it's helping us draw, I'm just going to write up, up, because that's easier to think about. So up, up. Hashtag awkward. All right, what are the x-intercepts?
3,
-3
-3, +4.
-3 and +4. What is the multiplicity of each of the x-intercepts? That's the exponent. No. It's a 2. And the 4 is 2. The multiplicity is just the exponent. All right. So I go over 1, 2, 3, 4, 5, put a dot at -3. 1, 2, 3, 4, 5, put a dot at 4. Okay, we're gonna say math on 3. 1, 2, 3. Math! All right. So, when it has a multiplicity of 2, what could it look like? When it has a multiplicity of 2, what can it look like? A little u. So if we are connecting to that arrow and we have to draw a little u, should the u be above or should it be below? Above. Okay, so we've got a u shape here. Okay, and then over here we have a multiplicity of 2 again, so we have a u shape again. And we have to connect to that arrow, so above or below? Above. So we got the U shape, it connects to the arrow, and then how do I connect these two? I just go straight across? No, it has to be a smooth curve. So if you want, you can make it a really tall curve, or if you're not feeling that, you could make it really shallow and have it just go across like this. The reason it does not matter is because we did not label our y-axis. Because curves don't work like that. These are always going to be curved lines. There would have to be, so think about when we graphed piecewise functions, the only time you can do something that is kind of like corner-ish like that is if you're doing a piecewise function and you're switching from one piece to another piece. If you're doing a function on its own, it's going to be a smooth curve. Yeah. Absolute value functions, but remember, we learned that absolute value functions are really piecewise functions, right? Where the left side of the v is a straight line and the right side of the v is a straight line. Yeah. I just blew his mind. You're welcome, David. All right, number 4. What is the degree for this problem? 5. 3 plus 2 is 5. We have a negative coefficient in the front. So for an odd degree with a negative coefficient, the arrow should go up, then down. Okay, so my arrow is going to go up over here and down over here. What are my x-intercepts? X equals 0, x equals 7. It's just thinking about the factors, how I would solve them. So anytime you have an x in the front, that's just 0. And then we did the opposite of the parentheses. Okay. All right, what's the multiplicity right here? 3. Multiplicity is 3. What's the multiplicity here? 2. Okay, so we've got 0, and then 1, 2, 3, 4, 5, 6, 7. Gonna have to move my arrow over a little bit. Okay. So when we go through the 3, we have 2 options, okay? We can go through the 3 like this, or sorry, go through the 0 with a multiplicity of 3. That's one option. Does that seem reasonable? No, it doesn't match our arrow, does it? The other option is we can go like this. So we want the second one. So I'm going to go ahead and erase what I drew. So we want that one. If your arrow's over here, you don't have to do that. Don't go connect it. Just like move your arrow, okay? Don't be a weirdo about it like I was, okay? Just there we go. There we go. Okay. Now over here we have a multiplicity of 2. That's the U shape. Should the U shape be above or should it be below? Below, because that's how we're going to connect the arrow. So I've got a U shape below. That makes more sense. And I'll go ahead and bring it down. I did. I put an arrow right here. We had one up here, and I erased it because it was like too far off my graph. This part? Because we got to connect them. We got to connect them. So how do I connect these two? Smooth curve. Make a little bubble out of it. Oh man, that was a good one. That was a good one. All right, next one. Woo. Some of these parentheses don't have numbers, so what should they have? What exponent should they have? They don't have an exponent written. That means it's a 1, 1, 1, 1. So the degree for this one is 6. And we have a negative coefficient. So an even degree with a negative coefficient tells us what for the arrows?
They're both going down.
Both going down. Down, down. Okay. So we have 1, 2, 3, 4. We have 4 x-intercepts this time. We have an x-intercept at -5, -1, and 5. Okay. So the multiplicity tells you what happens if you zoom in on the x. So when I zoom in and just look here, it had a multiplicity of 2. That's why it bounced. It looks like a mini parabola right there because it was a multiplicity of 2. It goes down because it was an even degree with a negative in the front. All right, so -5 has a multiplicity of 1. -1 has a multiplicity of 1. 2 has a multiplicity of 3. And 5 has a multiplicity of 1. Okay. Okay. So when we draw a multiplicity of 1, the multiplicity of 1 looks like a straight line, and we have to see if it should slant down to go through the point or if it should slant up to go through the point. Okay? So from your arrow, I'm going to move my arrow out a little bit further. Let me put my arrow over here. Should I slant up to go through the point or down? I should slant like this? I should slant up. Okay. So it should go through the point like that. Gosh, I keep putting my arrow in a bad spot. There we go. That makes more sense. Okay, so slant up to go through that. How am I going to do my multiplicity of 1 through -1? Should I slant up again? Yeah, slanting up would be weird, right? Because you'd have to like backtrack. And then you'd be like, oh, it doesn't pass the vertical line test. It's not a function. And then I'd be like, no, you just drew it weird. And then we would all point and laugh and make fun of you. I'm just kidding. That would be terrible. That would be terrible. All right, so this one's going to slant down. And then we got to make sure that we connect it nicely. Yeah.
Absolute value graph, because it has to connect with a smooth line.
Well, these are curved graphs. So an absolute value graph, like we were saying, is more like a piecewise function, where it's two linear functions connected. Here we don't technically have any linear functions. It's just a very curvy line. Yeah. All right. So through the 2 now, we have that multiplicity of 3. That means that we kind of squiggle as we go through the line. So we have 2 options. We've got this one right here, or we have this one. So which one should I do? The first one. The second one doesn't quite make sense. So we're going to do the first one. There's our multiplicity of 3. So you can see that when I draw it, what I did is I went up, I leveled out for a little bit, and then I kept going up. So go up, level out, go up. And then we'll make sure we connect these so it's a nice little curve there. All right, and then with the last one, I have to do a straight line because I have a multiplicity of 1. So should my line slant down or should it slant up? Slant down. So I'm going to draw that. And then I'll connect. There we go.
It's a squiggle.
It's a squiggle. It's a polynomial function. Now, if you were to graph this on your calculator, your y-axis would have to be like in the hundreds or thousands to be able to see this graph. So even though left and right, we only went left -5 and right +5, up and down we would have had to go to like 500 to be able to see. Because if you think about multiplying all these numbers together, you're taking a number, multiplying it by a number cubed. When you multiply by numbers, they get big fast. And so you would have really, really large numbers. All right, let's look at number 6. What's the degree for number 6? Degree is 9, okay? Degree is 9. We have a negative in the front. So we have an odd degree with a negative coefficient. So what does it do? Up and then down. So up and then down, and that makes sense, right? Because it's going to have a negative slant overall. It's going to go down overall. All right. So we have odd degree, negative coefficient goes up and then down. So it was a degree of 9, and it had a negative in the front of the equation. And so it goes up, then down. 9 is we added 3 plus 3 plus 3. All right, so our x-intercepts are what? 0, -4, and 2. And what's the multiplicity for each one? 3. Multiplicity of 3, multiplicity of 3, multiplicity of 3. I put this example in there because a lot of students don't like to draw the multiplicity of 3, so I'm forcing you to do it. I'm making you do it. That was pretty good, though. You gotta admit, that was a pretty solid evil laugh. You should be. All right. So when we draw this first one, should we go up, level off, go up? Or should we go down, level off, go down? Go down. We're going to do the other one. Okay, so I'm going to go ahead and erase this and draw it nice. So we're going to start at the arrow, and we're going to go down, and then level off, and then go down. So go down, level off, go down. Okay. Through that middle point, do we want to go up, level off, go up, or go down, level off, go down. Go up. So that's the one that makes sense. So you always have two options, and your common sense will help you choose between the two. Okay? I took up a lot of space drawing that one, and I made it way too close to the next one. Let me do a better job. Okay, now for this one, should we go up, level off, go up? Nope, that would be weird, right? We got to do the other way. So we're going to do go down, level off, go down. And then we got to connect those. Little bloop. And then here's my arrow. All right. We got it? We're good? Okay. Now, before we start our assignment, we're going to look at some graphs that are already drawn. And we're going to figure out the equation, okay? So, you do not have to write this. I'm going to write this down, okay? So, look at your notes. Your notes will help you figure it out. We have an up arrow and then a down arrow. So, is the degree going to be even or is it going to be odd? It's going to be odd because the arrows go opposite directions. And it's going to have a negative coefficient. So, when I write my equation for this, I'm going to start by saying y equals negative. Okay. Now, I have an x-intercept at 1, 2, 3, 4, 5, 6, 7, 8, 9. I have an x-intercept at negative 9. So what should I put in my parentheses? X plus 9. And what multiplicity does that have? Right there, if I cover everything else up, did it go straight through? Did it bounce off of the x-axis? Or did it squiggle as it went through? It went straight through, so that's a multiplicity of 1. It kind of curved, but did it do this? Did it do this? Okay. This one, we're going to call that an x-intercept of 0. So how do we write down an x-intercept of 0? We just put an x. It's weird to put it in the middle, but you can. Most people move it to the front. Okay. X, and then what is this multiplicity right here? Definitely a 3. Do you see the difference between a 1 and a 3 when we see the real life graph? Yeah, okay. And then over here we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's a positive 10. So what should I do? X minus 10 to the 1. Okay. Does that fit what we were expecting with an odd degree? Yes, that fits what we were expecting. Okay. So let's look at this one. Even degree or odd degree? Even, how do you know? Yeah, the arrows go the same way. They're both going up. Do we have a positive coefficient or a negative coefficient? Positive, I know because the arrows go up, not down. Okay, so our first x-intercept, 1, 2, 3, 4, 5, 6, 7, 8. Our first x-intercept is negative 8, so what should I write? X plus 8. What should I write next? 1, 2, 3, 4, maybe? I can't tell if that's 1 or not. Okay. 4. Okay. And then what's this one? X minus 4. And what's this one? And then why did we not put an exponent on any of those? They all go straight through, straight through, straight through, straight through. Okay, so those are pretty easy. All right, let's look at this one.
Well, it looks like a heartbeat. It looks like we injected himself with something.
Yeah, this would not be a good heart rate monitor, right? All right, do we have an even degree or an odd degree? Even, all right. Positive or a negative coefficient? Positive. Okay, what should I start writing? What do I put in the parentheses? X plus 2 All right, what multiplicity did it have? A squared. A squared. You see how it bounced? Yeah, that's a mini parabola right there. Okay, so that's a squared. It could be. Yeah. All right, what about the next one? Cubed, okay. This is not 1. That's a y-intercept, not an x-intercept, so we skip it. We don't do that. All right. X minus 1. X minus 1 squared. Okay, and then the last one with no exponent because it would be a multiplicity of 1. To the first. You could put to the first if you wanted. Okay. Let's try this one. You don't. We don't. The way that you would show that is it would tell you what the stretch of the graph was. We haven't been putting coefficients in front of these, so it would just allow you to put a coefficient in the front that's a number. Yeah. All right, so for this one, we're going to say y equals, is this an even degree or an odd degree? Odd. Is it a positive coefficient or a negative coefficient? Positive, right, Sierra? She was looking at the graph through her eyelids. Like this. All right, so we have an odd degree and we have a positive coefficient. What do we see first? X plus 1 squared, okay? X minus 2 cubed, yeah, because it definitely doesn't go straight through, right? It looks too weird to go straight through. Okay, let's do this one. Is that even degree or odd degree? Odd. Positive, because it goes from down to up, right? Down arrow to up arrow, so positive. All right, what should I write first? X plus 3 cubed. So this squiggles as it goes through, and that's how we know it was a 3. Because if it went straight through, it would be, oh, the degree you said. We know the degree because the arrows go opposite directions. So if we look at our notes, even degrees have arrows that go the same direction, up, up, or down, down. Odd degree have arrows that go opposite directions. All right, so we have x plus 3 to the third, and then what do we have? X minus 4, and then what do we have? X minus 7. And why did we not put exponents on those? Yeah, they're straight lines, they're both 1s. Okay, this will be the last one, and then we can get started. Get started. All right. Y equals even degree or odd? Even. Positive coefficient or negative coefficient? Negative. Okay. What should we write first? X plus 4 squared. Miss Rice, we want a quiz on this. That's why we're not listening anymore. What? Oh, what? What? Yeah. All right. What should I write next? X plus 1 cubed, because we did that right there. And then with no exponent. It's not dimensions. It's just a number in cubic. All right. So what I have for you is lots of these. Yes, Miss Rice, I love this. And then some where you have to graph them yourself. What a marvelous assignment. And then I give you a real good one. man. Gonna be good. Gonna be good.